Swayam Prabha. Digital India. Educated India.
Hello everyone. So, we are discussing the air filtration. So, as we know that filtration is required to separate contaminants from fluid. So, the contaminants are in the fluid, in this case the medium is air, okay, and the contaminants are of different types like small particles and all this, and also separate the value added materials. It may be reversed. So, in air filtration and all this, what we try to do, we try to clean the air, or in water filtration we try to clean the water, but we can also separate the value added material like minerals, chemicals, foodstuff from the fluid stream. So, both the things we can do with the filtration, and nonwoven is very widely used for this filtration, both water and air filtration, because of its porosity. Now, if you see the air filtration, it is required to separate various contaminants present in the air, so that we can breathe pure air. So, that was our basic idea. Now, let us try to see what are these contaminants in the air and their dimensions. If we have clear idea about the contaminants and their dimensions, then we can create our nonwoven accordingly. So, if you see here, like these dimensions are in microns. So, if you start with the coarser particle like lint, okay, beach sand, human hair, these are actually sometimes the coarse particles are sometimes floats on the air, 100 to 1000 micron. Then between 10 to 100 micron, we can coal dust, milled flour, pollen. Okay. So, these are basically harmful. Then from 1 micron to 10 micron, you can see in this range bacteria, coal dust. So, very small particles, and if you go towards the finer particle, you can see this is colloidal silica, tobacco smoke, carbon black, even virus dimension is 0.01 to 0.1 micron, diesel soot is in this range, smog is in this range. So, this particles we have to prevent from entering in our body, and we have to use the filter media, and we can go towards the very smaller particles also, but in general the textile filter media we can use to arrest the particles from 0.01 and above. So, these are the particles which floats in the air, and we have to use the filter media. Now, we will try to understand the filtration, the mechanisms. Now, filtration is of two types. One is surface filtration and another is depth filter. So, surface filters are the filters where this is the filter media. If it is surface filter, then the pore size of the filter media is less than the particle size. That means, where the particles are getting settled at the surface of the filter media. This filter media may be only fabric or may be fabric along with the dust cake, and depth filtration where the particles are actually stopped from moving across the filter media within the structure. At certain depth the particles are stopped. So, surface filtration, if you see, so it is used for cake filtration, in which the solid particles are deposited to form a cake on the upstream side of the filter. Suppose this is a filter medium. Now, the air stream is coming, this is the upstream side, and air stream is carrying the solid particles. Okay. Now, there may be very small particles, may be large particles. The small particles, what it will do? It will allow the small particles will move through this on the other side, or it may be arrested within the structure, but the larger particles will form cakes on the surface initially, then the pore size will get reduced gradually. Even after certain time, proper cake formation will be there, and then it will start filtering the small particles also. This deposition is on the upstream side, and in the downstream side we get clean air. So, that is the surface filtration. Now, you can see here the suspension is there, and where with the time initially the smaller particles escaped through the pores, but after certain time there is a cake formation, and the advantage here is that you see the particles are arranged randomly, where the particles also form a porous medium. There are pores available. So, if you see the particles, if we assume it is a spherical, still there will be pores in between the particles. So, that porous structure will be formed, so that air can pass through, but still it will stop the smallest particle to flow through this cake. So, this is the surface deposition of the cake helps in the increasing the filtration efficiency, although it increases the pressure drop to some extent, but after certain time we can remove this surface cake form which has been formed. Okay. Now, next is the depth filtration. Before that, we just try to see how is it forming. So, direction of air flow here, air is flowing and small particles are going on the other side. So, the large particle, it will initially start capturing the larger particle, then when cake will start forming, and after that it will start capturing the smaller particles also. So, this textile filter expressed as a set of cylinders placed in parallel. So, if we assume the textile filter, although this is not the case for nonwoven fabric, nonwoven fabric the pores are not the continuous, not all the pores are continuous. There will be blind pores where pores are stopped, ended at the within the thickness of the fabric, and the pores are also not behaving like a cylindrical pore. These pores are irregular in shape, but if you see for the woven fabric we can consider the pores are straight. So, for woven fabric we get this type of phenomena, surface filtration, and in nonwoven fabric we get both surface filtration and depth filtration, that we will discuss. All particles which are bigger than the pores are captured on the flat filter surface. Flat filter surface is provided by the mainly by woven fabric, but in nonwoven also we can get, particularly thin nonwoven fabric like spun bonded heat shield fabric, there we can get the surface filtration. So, typical example is the woven fabric or spun bond filters. So, for this type of fabric we get through pores, that means pores are connected from the surface upstream side to the downstream side. Thus, for these filters the pore distribution and permeability are important properties. So, and this is called flat filtration, and this flat filtration is very commonly used for liquid filtration, and particularly where we want to take the filtrate. Filtrate is the our main idea to take like the food stuff filtration. So, there we can get this type of filters. Next is the depth filtration used for deep bed filter. So, deep bed filtration in which the particles deposited inside the medium and where cake deposition on the surface is undesirable. So, we want to deposit the particle inside the surface. So, you can see here this is a suspension, the particles are coming, particles are deposited inside the surface. That means, here we need certain thickness, thicker material, porous material we need. The particles, even the smallest particle are deposited, like bacteria, virus can be deposited within the structure, they are not deposited in the surface. So, for very minute particles we need this type of depth filtration. So, the mechanism we will discuss the what are the different mechanisms. So, depth filters you can see here. So, depth filters are able to capture the particles that are too small to sieve. So, surface filtration is used for larger particles and depth filtration is used for very small particles. Okay. So, particles which can be smaller than distance between the fibers. So, that means if this is the fiber dimension, here distance between the fiber is larger, it can trap even a smaller size particle, very small particle, because the path is not straight and the pores are not continuous. So, particle if when it enters through the large pore, it will strike one of the fiber surface and get settled there. So, even a very small particles we can filter out. So, filtered particles are captured in terms of filtration mechanism. Now, here these particles, it will be captured based on the filtration mechanism. So, how will it be captured? So, there are different filtration mechanisms are there, that we will discuss. So, filtration mechanisms, actually which filtration mechanism will be applied, that depends on the mainly fiber dimension, sorry, particle dimension, and also the speed of the air. So, air flow rate and the particle dimension. So, larger particle will follow certain mechanism, and very small particle like bacteria or virus, that will follow a different mechanism, that we will discuss. Here you can see the particles are moving and captured during its flow through the, this is the thickness of the porous medium, and during its flow these particles are getting captured within the structure, and very small amount, even we can design by multilayer clothing, multilayer filter, we can make it 0, no particles will pass through, still the air can flow through. So, that is the mechanism we will discuss here. This type of filtration process is important for most of the filter application. So, for large particle we depend on this surface filtration, and for depth filtration most of the particles, where we are dealing with a very small particles, we cannot produce a fabric with a very small narrow pore size, because it will enhance the air pressure. So, pressure drop will be enhanced. So, we should keep the pore size larger, so that air can flow through easily, but at the same time we should design our filter media, so that particles are captured within the thickness of the filter media. Now, see there are different standards that we will discuss. One standard is that American Society of Heating, Refrigeration and Air Conditioning Engineering, ASHRAE, ASHRAY. So, RAE. So, that this is the standard for filtration. They actually express in terms of MERV, like minimum efficiency reporting value, that is their standard, and they express the MERV value based on the dust holding capacity and dust weight arrestance. So, that MERV value, that ranges from 1 to say 20, that So, higher MERV value means the particle can capture finer particle, So, the filter can capture the finer particle, and lower value means its filtration capacity is less, but it can hold the larger particle. So, let us see the MERV ratings. What are the different types of ratings here? So, that measures the effectiveness of air filter capturing the airborne particles, with higher value indicating the better filtration of smaller particles. Like lower value means it will capture the larger particles effectively, but higher MERV rating means it will capture the smaller particles. Obviously, it will capture the larger particle also. So, developed by ASHRAE, that MERV rating, and the scale of range is, as I have mentioned, 1 to 20, balancing the air quality need against the HVAC, that is heating, ventilation and air conditioning system. So, that type of rating is used for HVAC filter, HVAC. So, MERV rating is its minimum efficiency reporting value. As I have mentioned, it is actually, it rates the filter on the ability to capture from 0.3 micron to 10 microns. Within that range, how the filter is capturing, what is the capability. So, this range include dust, pollen, bacteria, smoke, all these things they take into consideration, and tested across 3 size range. The E1 is a range. So, E1 rating you will get, the range is the 0.3 to 1 micron, then E2 rating 1 to 3 micron, and E3 is a for coarser particle 3 to 10 micron. So, E1 is responsible for finer particle, that range. Okay. So, let us see the overview of MERV rating. The scale runs from 1, that is basic filter, it will be able to capture very coarse particle, and up to 20 MERV value, which is HEPA filtered, like very efficient, it can capture the very fine particle. Okay. But the commonly used range is 1 to 16, that is rating is commonly. So, 1 to 16 rating is used, but 20 above 16 is for very specialized application. Higher MERV means finer particle capturing capacity, and the more air flow resistance, that we have, that pore size will be smaller, air flow resistance will be high. That means finer MERV. So, higher MERV will be used, the filter with higher MERV rating can be used where air flow rate is not a problem, air flow rate is very small, very low, like in a clean room. So, at the end we can have higher MERV rating above 16, but when the air flow rate is high, okay, in that case we must use the lower MERV rating at the initial stage. So, in case of very clean room or hospital, where even we do not allow any bacteria to come, MERV rating 17 plus. So, more than 17 is used, like we use a HEPA filter. Now, this is the typical range. For pollen, dust, okay, large particle, we use the filter with a rating 1 to 4 depending on our requirement. So, dust, mold, so this type of finer particle 3 micron and above particle, we use MERV rating, little bit higher rating. Here it will 5 to 8, auto emission, okay, lead dust or 1 to 3 micron range, we use 9 to 12 rating, and bacteria, smoke, viruses. So, 0.3 micron and above, here we use 13 to 16, and if we need more than that, better cleaning, better air, cleaner air. So, we can go for 16 and above. Okay. So, you can see here if we go from MERV 1 to 16, we are going towards the finer particle, but their air pressure also increases, the air pressure, that pressure drop will also increase. So, where if we use the high speed airflow, when the air flow rate is high, in those applications we should use the lower MERV range, but in clean room or in hospital their air flow rate is smaller. So, lower rate. So, in that case we can go for the higher MERV rating. So, basic MERV rating 1 to 4. So, these are used for residential purpose, where it captures large debris like carpet, fiber, pollen. So, MERV for basic residential application, we use this filter for with a range of MERV 1 to 4 for capturing the larger particles. So, ideal for window AC, okay, low budget homes, okay. So, which where minimum air quality index. Okay. So, internal air quality, if we see, though it will improve the internal air quality to a lower extent, because it is only capturing the large particles, allowing the smaller particles. So, airflow stays high, no system strain. So, where I have mentioned where we need higher airflow, like in AC. So, where higher airflow is required, there we cannot use higher MERV value, then it will actually load the AC, air conditioning system. So, there we have to capture the only larger particle, that much compromise we have to do. MERV for from 5 to 8. So, standard home use. So, filters with a rating MERV 5 to 8, we for normal home use we can apply. So, common residential application, okay, trap household dust, lint, spores. So, we can for better than MERV 1 to 4. So, but some agencies for home, they recommend at least MERV 8, okay, for energy efficient home. So, MERV 8 they recommend, because it will capture the dust, finer dust also, at the same time the pressure drop is not too high. So, energy, the home will be energy efficient. So, energy consumption will be on the lower side. So, it balance the cost is it will not increase due to the energy optimum energy consumption. It will allow the flow rate also, okay, and at the same time it will remove the allergic dust. So, MERV 8 is basically optimum for home application. If we need better protection, there we have to go for higher MERV rating 12 to 9 to 12. So, effective dust filter for fine dust, smog, okay, suit superior residential or light commercial HVAC, that in the commercial vehicle where we need cleaner environment, and there continuously high dust particles are there in the air. So, even from the vehicle it exhaust we get different types of particle. For those applications we need MERV rating 9 to 12. It improves the internal air quality better than earlier. So, without measure pressure drop. So, pressure drop is there, but it is not too high. Now, 13 to 16 we need MERV level 13 to 16 we need only in those places where high efficiency filtration is important. Even a small particles we need to arrest, but main thing we should keep in mind, their air velocity should not be very high. So, our air requirement, air velocity requirement should not be very high. So, it captures bacteria, tobacco smoke, virus. So, more than 75 between 75 to 95% filtration efficiency we can achieve by using MERV 13 to 16. If we want to get more clean, so we have to go 16 and above, we have to go for that MERV rating, but up between 13 to 16 it gives very good efficiency used in hospital, schools, okay, and this is suggested for the virus capture. So, this type of air filters are used particularly in the face mask. We can get this type of rating requires for HVAC check for air flow. So, basically it is actually, if we try to use this range 13 to 16, we have to go for the air flow checking. So, pressure drop should not be too high. So, it should allow the pressure drop, but here if we use 13 to 16. So, air flow rate should be of the system should be low. If the air flow rate is high, then we cannot, if the air flow rate is high, then we cannot have higher MERV rating. So, that type of filter we have to check what is the air flow rate. If it is air flow rate is low, then we can go for the MERV rating 13 to 16, that type of applications we have to see. Now, let us see how to choose the right MERV. So, we have to match the need. So, MERV 8 for home and 13 plus for health services, that rating is there. For home we go for MERV rating 8, and for hospital and for doctors or someone is going to hospital or clean room, in those case we should go for anything above 13, but here we have to keep in mind the air flow requirement. So, for hospital, suppose hospital where we need air flow, so air conditioning, there we cannot go for very high that MERV rating 13 will be useful. So, depending on the air flow rate we have to decide. So, higher rating reduces the air flow. So, it may increase the energy cost, that we have to consider, and also it will strain the system, total filtration system, the pressure will be there, bursting pressure, the filter can get damaged. So, that optimization we have to do between the this filtration efficiency and air flow. So, that there is a specs available. So, we have to consult that, and we have to change the filters regularly. If we do not change the filter regularly or clean the filter regularly, then it will gradually increase the pressure drop, which will increase the energy cost. That also we will discuss subsequently, how the pressure drop is changing with the time. So, higher MERV means smaller particle trapped, better air quality. So, these are the key takeaways. So, the key takeaways are the trade off, main trade off is that always in any filtration the main trade off is air flow. If we need higher air flow, we have to sacrifice the pressure filtration efficiency. So, that we have to test our system, which filtration efficiency is required, what type of air flow we need, accordingly we decide the MERV rating. So, there are different guidelines available, EPA and ASHRAE guidelines for selection of home filters. Now, try to see the different types of places where and the particle size and what type of MERV rating we can use. Now, these are the different ranges 1 to 12 range, these are not the MERV rating basically. Now, you can see the geometrical mean is 0.35. So, 0.3 to 0.4 or maybe 0.4, 0.55, these are the different ranges available, and in this range if you see in the finer range, if we see allows the evaluation of the filtered efficiency on respirable size particles. So, this is actually here the particles which we take inhale this type of particle respirable particles. So, in this range, in this zone, these particles are there, for that we need the different types of rating, and as per the standard these are standards are given, and typically between say 6 to 12 there is a coarser particle. So, allows the selection of filter based upon the most common particles of contaminant. So, these are the respirable particles and these are the most commonly available particles. So, we have to decide depending on the particle size distribution, and we have to select the particular filter medium with a certain MERV rating. Okay. Now, try to see this one. Here MERV rating, if it is 14, this is 14 means very high filtration, very small particle pore size. Okay. So, here the particle size is given, okay, and these are the respirable particles as we have seen. So, MERV 14 here 95% will be the filtration efficiency, more than 95%. You can see within this particle range typically applied as the final filter in the hospital. So, there will be different layers of filter. So, this is the outside air coming, initial pre-filter, one layer, two, this is the final layer. If the air flow is in this direction and this is carrying the particles, different particles. Now, here this layer will be MERV. Now, let me draw again. So, this is the layer. Now, here next layer will be, say, this is the layer, third layer is fourth layer will be, and say fifth layer. Okay. Now, here if you see, this is the final layer. What we are using, this one is the MERV 14, very fine particles are there, fine pore size are there. Now, in hospital if you try to use this, it will be final layer, where after filtration of the very coarser particles, only fine particles will be captured by MERV 14. Now, during the air flow, if you see here, this as by the time it is reaching at this stage, the air flow rate will be reduced. So, it can capture the very, very small particles, very small particle with the efficiency is more than say 75% typically. And for normal hospital case, we can see here at this range we can achieve the filtration 95%, above 95% we can achieve. Now, next one is the MERV say 13, little bit porous structure, more porous than MERV 14. Now, typically applied in the above average commercial application. So, it is a in any commercial application like your even in hospital we can use these things, where we need better than the normal cleaning, like in school and in any enclosed place we can use this one as a final layer, okay, where the filtration efficiency will be typically 85%. Next, if we see, and this one is the little bit coarser, MERV 11, applied in standard commercial building such as office space, we can use this one, where the filtration efficiency will be little bit lower. For average filtration efficiency, if you see, this will be typically 65% for a particle around say in 1 to 2 micron, and for higher micron we get the filtration efficiency, higher filtration efficiency. Now, next one is MERV 6 to 7. So, there this is MERV 6 to 7, next layer you can see it is used for pleated filter, where air speed is required for automobile, okay, and pleated filter with the office environment and all. So, there larger particles will be captured more, but for finer particle the filtration efficiency is very low. So, larger particle it can give the filtration efficiency typically around 20-25%, and MERV 1 to 5 typically say polyester or fiberglass, these are used for very large particle, and these are used for very large particle, and they are basically washable. So, like metal mesh, so washable filter. So, large particle it arrests only. So, these are the typical range of MERV. Now, this guideline is very important. So, 1 to 4. So, larger than 10 microns will be arrested. So, these are different types of dust, pollen dust, paint spray, and minimum filtration residential window air conditioner we can use, where large air flow rate is required, very high air flow rate with the lower pressure is required. So, from the environment, so large particles are arrested here. 5 to 8, it is typically for commercial buildings, better residential that we have used explained. 9 to 12 for finer particle, 1 to 3 microns like lead dust, coal dust, auto emission. So, there it is used at the superior residential buildings, better commercial vehicle, hospital and laboratory. So, we use MERV 9 to 12 and MERV 13 to 16. Within that range, if we want better cleaning like from bacteria, tobacco smoke and droplet nuclei. So, that is actually used those this in this range we use in the where places where we need better very good filtration like hospital, in ICU and all this, there we can read general surgery. So, there we use this type of, and in ICU and all this if we need much better. So, we can go for MERV rating 16 and above. So, these are the different ratings here. Now, we will discuss the filtration mechanism. So, types of filter we have used. So, types of filtrations are surface filtration and depth filtration. Now, we will discuss the filtration mechanism. So, there are that how the particles are trapped from the fluid stream. So, that is the mechanism. There are separate mechanisms for that is surface loading and cake filtration. So, these are the different mechanisms for basically filtration, and this surface loading is different from the surface filtration and depth loading. So, depth loading is different from depth filtration, depth loading we are talking about and depth filtration. So, these are the different mechanisms of the filtration like surface loading, cake filtration, depth loading and depth filtration. Now, let us see the surface loading. Surface loading means if we use a filter media with discrete clear pores like oven fabric or spun bonded heat shield non oven fabric thin, these are used basically for thin filter media, and the larger particles will get arrested on the surface, it will be loaded on the surface. That is why it is called surface loading. So, any filtration as this will follow all this. For textile material, the filtration will follow all these 4 mechanisms, but for woven fabric or very thin spun bonded, they will follow the surface loading and cake filtration. So, it is loaded, particles larger than the pore size cannot pass through and get separated from the filtration the fluid, and the smaller particles will pass through, and gradually the surface will be loaded, particles smaller than that can pass, that initially will allow the smaller particle to pass through, so that the cake formation is there. This is the case where fibrous filter with uniform pore size like woven fabrics or spun bonded non-woven, thin non-woven, this type of surface loading take place, flow direction. This involves the capture of particle on the surface. Okay. So, cake filtration, if you see here, the capture of particles are on the surface. Okay. Like this is a porous medium and the particles are captured on the surface. So, cake formation is there, and this cake which acts as a filter medium, additional filter medium. So, this may be the case with non-woven fabrics, however, it is rarely used. So, cake filtration is there, we can generate, like cake filtration is for geotextile, cake filtration is important, and sometime we preform the cake with the, initially we create the cake on the fabric surface, so that from the beginning there is a filtration is high. So, I have already explained how the cake formation is there. That formed cake, the fabric, filter fabric with the cake is used from the beginning, so that the smaller particle can be arrested from the beginning. Now, depth loading. So, this depth loading, it is different from depth filtration. So, particles penetrated, that it penetrate inside the structure. Now, I will discuss. So, here there is a clear formation, clear particles paths. So, particles will not be arrested there, like in case of say woven fabric, but in case of non-woven fabric, due to its tortuous path, particles will be trapped somewhere where the pore size, the point where the pore size becomes smaller than the particle size. Like this is the, suppose this is the pore and particle is moving, this particle when it is moving, it will be trapped at this point, because the pore dimension is not uniform. So, at this point you can see this particle is getting trapped. So, here the pore dimension. So, this place in the depth of the structure at a within its depth. So, particles are trapped. This is the case with a thicker fibrous structure like non-woven, needle punch non-woven, a thick fibrous structure, this type of depth loading is taking place. So, depth loading is very important. Here the advantage is that it will keep the porous structure intact. So, not all the pores will be blocked. So, the air can flow easily, but main problem here is that it will be loaded and the cleaning will be difficult. If we want to reuse this filter medium, that loading, that if we in that case the cleaning of these particles which are trapped within the structure is very difficult. But surface loading, that can be cleaned by simply shaking or reverse airflow. So, that is the problem here, but for various applications like a filter that is a face mask and all, where we do not reuse this, in those cases this we need the smaller particles to be captured. So, there depth loading principle is used, and then the depth filtration. Depth filtration is actually different from the depth loading. This is different from depth loading, as it involves a specific mechanism to capture the particle inside. So, here depth filtration, so this is the fabric, depth loading what we have discussed. A particle is captured somewhere inside the structure where the pore size is smaller than the particle size. So, that is called depth loading, but depth filtration, where particle enters within the structure, this is the thickness of the material. So, it will particle is entering into the structure, but getting stopped within the within the thickness. So, that is basically, and then the clean air is moving outside. This is upstream side, it is a downstream side, but these particles are captured with a different mechanism, using different mechanism irrespective of the size. Even the smallest particle, very small particle like virus, that can be captured by the nonwoven fabric with a much more particle pore size, that also can be captured. So, as it involved specific mechanisms. So, mechanisms we will discuss and how this mechanisms help in capturing this particle inside the fibrous structure, that we are going to discuss here, regardless of the particle size is higher or smaller than the pore size. Even for a particle smaller than the pore size, that can be captured within the structure using the depth filtration. So, depth loading is different. Depth loading is, it is physically it is captured by the smaller pore in the structure, but the smallest particle, very small particle, even if it is larger, the smaller than the pore size present, that also will get captured within the structure. So, those are actually the filtration mechanism, they follow different filtration mechanisms. Now, thus mechanisms are of different types of mechanism that we will discuss. Now, here this is the thing, you can see this particle size is smaller than the pore size. Okay. This is the particle size is larger than the pore size, that is will be trapped inside, it is called depth loading, and here the particle size is smaller than the pore size. But even then this particle will be captured and they will follow certain mechanism. That mechanism we are going to discuss subsequently. Now, you can see the smaller particles are captured somewhere, okay. And this is the case with porous and voluminous fibrous filter like non-woven filter. So, for non-woven filter, very porous filter where the air flow rate will be high, pressure drop will be low, but still the fibers can be captured, that particles can be captured by the porous medium using different mechanism. So, particle capturing mechanisms are there are various mechanisms. The most commonly used mechanisms are inertial impaction, that we will discuss in detail. Inertial impaction, where the particle will is moving at very high speed with higher inertia, that will actually strike the fiber surface. So, that inertial impaction, direct interception, then Brownian diffusion, gravity settling, electrostatic charges. So, these are the different ways to capture the particle. So, filtration mechanisms that we will discuss in the next session. Till then, thank you.